Welcome to the deep dive. We're jumping straight into a core idea in programming today, managing collections of related values. Not just one piece of data, but whole groups of them in one structure.
Yeah, think of it like organizing tools in a toolbox instead of leaving them scattered everywhere. Makes things much tidier.
Good analogy. And to really make it practical, imagine you're working security for an online store.
Okay.
Orders are flying in, right? And you need to spot the suspicious ones quickly. Handling them one by one is slow. What if you could group them?
Exactly. Looking at them as a set makes much more sense.
And that's where our source material comes in handy today. We're looking at how to manage these sequences, these ordered lists, using something called arrays in C#.
Right, arrays. They're like special containers designed just for this purpose, holding related bits of data together.
So our goal today is to really get into arrays, how you make them, how you put stuff in, take stuff out, and, work with all the data inside efficiently.
Yep. Consider this your fast track to understanding a really fundamental coding concept.
Okay, let's get into it then. Fundamentally, what is an array?
Well, simply put, it's a collection of individual data elements. But the key is you access all of them through a single variable name.
Like a shelf with numbered slots, maybe, and the shelf has one name.
That's a perfect way to think about it. And each slot, each element has its own unique number.
So how do you refer to a specific slot, a specific item?
You use what's called an index. And in C#, like many languages, it's a zero-based index.
Zero-based, meaning the first item is at index 0.
Exactly. The first item is index 0, the second is index 1, the third is index 2, and so on. Feels a little weird at first, I know.
Yeah, starting counts at 0 always takes a moment to click.
It does, but you get used to it. It's super common in programming.
So back to our store security example, we could have an array, maybe call it fraudulent order IDs. And fraudulent order ID 0 would hold the first suspicious ID, fraudulent order IDs 1 the second, and so on.
Precisely. The real benefit is grouping things with a common purpose. Those order IDs, maybe the list of student names, daily temperatures, anything that belongs together. It makes processing them as a unit so much easier.
Okay, I get the what and the why. How do we actually make one in C#? What's the syntax look like?
Right, so the declaration looks like this. String fraudulent order IDs equals new string 3.
Okay, whoa. Let's break that down.
Sure. First part, string. That tells C# what kind of data this array will hold. In this case, text strings for our order IDs.
Got it.
Then you see the square brackets.
Yeah.
That's the signal. That tells C# this isn't just one string, it's an array of strings.
The brackets mean array. Makes
Yeah.
sense.
Yep. Then fraudulent order IDs, that's just the name we're giving our array variable.
Yeah.
After the equal sign, we have the new keyword. New basically tells the computer, allocate some memory for this thing I'm about to create.
Creating a new instance of an array.
Exactly. And new string 3 specifies what kind of array, a string array, and crucially, how big it should be. The 3 means make space for exactly 3 string elements.
So string is the type, fraudulent order IDs is the name, and new string 3 actually builds the container in memory for 3 strings.
You've absolutely nailed it. And remember, while we're using string here, arrays work for any data type. You can have int for numbers, bool for true-false values, anything.
Very versatile. Okay, so we've declared it. We've got this empty container for 3 strings. How do we fill it up? How do we assign those order IDs?
You use the index again. You assign a value to a specific slot using its index number inside the square bracket.
Ah, like putting things on that numbered shelf.
Exactly. So it would look like fraudulent order ID 0 equals A123.
Index 0, the first slot.
Okay. Then maybe fraudulent order IDs 1 equals B456.
Second slot.
And fraudulent order IDs 2, C789 for the third and final slot in our size 3 array.
Right, indices 0, 1, and 2 for a 3-element array. That 0 base thing again still feels a bit odd. Why do they start at 0? Is there a reason?
It's a good question. It often relates back to how memory addresses are calculated, sort of an offset from a starting point. It might seem quirky, but honestly, it becomes second nature pretty quickly, and it's very consistent across languages.
Okay, fair enough. Consistency is good. So we're basically saying put A123 in slot 0, B456 in slot 1.
Yep, that's the process. Now, here's a really common trip up, a pitfall.
Oh.
What do you think happens if we have our array of size 3, indices 0, 1, 2, and we try to access, say, index 3?
Index 3 would be the 4th slot, but we only made 3 slots. Sounds like reaching for something that isn't there. That can't be good.
You're spot on. It's not good at all.
Yeah.
If you try to use an index that's outside the valid range for the array, like index 3, your program will crash when it tries to run that line.
Crash, like just stop working.
Yep. It throws a specific error called a system.indexOutOfRange exception. It's a runtime error.
Runtime, meaning it happens when the program is actually running, not when you first write or compile the code.
Exactly. Your code might look fine, it'll compile okay, but boom, when it hits that line trying to access the non-existent element, it halts and tells you about the index being out of range.
I think our source material mentioned an exercise that does this deliberately.
It does. And the good thing is, the error message is usually very specific. It tells you exactly which line caused the problem, making it easier to find and fix. It's a sharp lesson in respecting array boundaries.
Definitely sounds like something to watch out for. Okay, so we know how to put values in, how to get them back out. Say, I just want to print the first fraudulent ID.
It's logical, right? You use the same index notation to get the value at index 0. You just use fraudulent order ID 0.
So I could do something like console, right line, first ID.
Fraudulent order user.
Perfect. That would fetch the string stored at index 0A123 in our initial setup and display it.
Simple enough. Now, what if we make a mistake? Say, order A123 turns out to be fine, but we find a new suspicious one, F1000. Can we change the value in slot 0? Yes, absolutely. Array elements behave just like regular variables in that sense. Their values aren't set in stone.
So you can just assign a new value?
Yep. You'd simply write fraudulent order D0 is our 0, 0, 0, 0. The new value F1000 just overwrites whatever was previously stored in index 0.
Okay, that makes sense. Declare, assign, access, reassign. Got it. Now, assigning them one by one, like 0, 1 equals, seems a bit verbose if you already know the initial values. Is there a shortcut?
There absolutely is.
Hmm.
C# provides a much more concise way to declare an array and initialize it with values all in one go.
Ah, like shortcuts. How does that look?
So in newer versions of C# version 12 onwards, you can use something called a collection expression. It looks like this. String fraudulent order is equals A123, B4586, C78 minus.
Oh, I see. You declare it like before, but then use square brackets again with the actual values inside separated by commas.
Exactly. Much cleaner, right? It infers the size from the number of values you provide.
Yeah, that's way neater.
And, just so you know, the source material also points out the older syntax, which still works perfectly fine. It uses curly braces instead. String fraudulent order is A123, B456, C789.
So square brackets for the newer style, curly braces for the older style, but they both do the same thing, create the array and fill it immediately.
Precisely. Same result, just a slight difference in syntax. Both are common, so it's good to recognize both forms.
Good to know there are options. Okay, so sometimes we might create an array, or maybe we get one from somewhere else, and we don't know exactly how big it is offhand. Is there a way to ask the array, hey, how many slots do you have?
Yes, and that's super important. Every array has a built-in property called length.
Length. Okay.
If you access fraudulent order is length, it will give you the total number of elements the array can hold.
So for our example array, fraudulent order is length would return 3.
Exactly. 3. It gives you the actual count of elements, not the highest index number. Remember, the highest index is always length 1 because of that 0 base start.
Ah, right. Length is the count. 1, 2, 3. Index is the position. 0, 1, 2.
Got it. That seems incredibly useful if you're, say, reading data into an array and don't know how much is coming.
Absolutely. You often use the length property to control loops or know how many items you need to process. You could write console.writeLine processing fraudulent orders porters, and it would always show the right number.
Okay, this is great. We can create them, fill them, change them, find their size. Now, what about processing all the items? If we have, say, 100 order IDs, writing console, write line, fraudulent order IDs 0, console, write line, fraudulent order Ds 1, all the way to 99 seems painful.
Oh, definitely painful and very error-prone. Thankfully, C# has a much better way, the foreach loop, or foreach statement.
Foreach, I've heard of that. How does it work with arrays?
It's designed specifically for iterating over collections like arrays. It automatically goes through each element in the array one by one from the first index 0 to the last, length 1, without you needing to manually manage the index number at all. Okay, that sounds promising. Less manual index tracking means fewer chances for those index out of range exception errors, right?
Exactly. It's generally safer and often easier to read.
So can you show me an example, maybe with a simple array of names?
Sure. Let's say you have string names, Rowena, Robin.
How?
You can loop through them like this. C# foreach, string name and names. Console, write line, name.
Okay, let's unpack that. Foreach. Then in parentheses, string name in names. What's happening there?
Right. Names is the array we want to loop through. String name declares a temporary variable, name. that will hold the value of each element as the loop progresses. So the first time through, name will be Rowena. The second time, name will be Robin. The third time, Bow.
And then the code inside the curly braces console write line runs for each of those values.
Precisely. So that loop would just print each name on a new line. Super straightforward.
I can see how that would be perfect for our order IDs. Just loop through each one and maybe perform some check on it.
Exactly. Let's take another practical example from the source. Imagine a warehouse using bins for inventory.
Okay.
They might have an array of integers representing the number of items in each bin. Int inventory, 200, 450, 700, 175, 250.
And they want to calculate the total inventory across all bins.
Yeah, you could use foreach for that easily. You'd start with a total, say, int sum to 0.
Right. Initialize a sum to 0.
Then you'd loop foreach, int items in inventory.
So items is our temporary variable holding the count from one bin at a time.
Correct. Inside the loop, you just add that bin's count to the total sum plus items.
Simple addition for each item in the array.
Yep. And you can even track which bin you're on. The source shows an example where they print the bin number, the items in that bin, and the running total as it iterates.
That really brings it to life, seeing the loop progress and the sum build up. Okay, let's connect this back to our original problem, the online retailer's security team.
Right, the fraudulent orders.
We've got our array of order it. Now let's say the team notices that orders starting with the letter B are highly suspicious. How can we use arrays and loops to find only those B orders?
Okay, a practical filtering task. This is a great challenge. So given an array like string order IDs, B123, C234, A345, C15, B177, G3003, C235, B179.
We need to pick out just the ones starting with B.
Exactly. We need a way to check if a string starts with a specific character or sequence of characters.
Does C# have something built in for that, like a starts with function?
It does indeed. String variables have a method called starts with. You call it on the string and pass in the prefix you're looking for.
So if I have a variable my order containing B123, then my order starts with B would return.
Correct. And if my order was C234, my order starts with B would return false.
Perfect.
Yeah.
That's exactly the tool we need. So putting it together, we use foreach to loop through every ordered in our ordered array. And inside the loop, we'd use an if statement. The condition for the if would be ordered starts with B.
You got it.
And if that condition is true, then we print out that ordered ID.
That's the logic precisely. Loop through everything, check each one with starts with B, and only act on the ones that match.
So for that specific list of IDs you gave earlier, B123, C234, A345, C15, B177, G3003, C235, B179, what would the output be?
The output would just be the lines that start with B, B123, B177, B179.
Right, just those three. And the code itself, based on what we discussed and what's in the source, would look pretty clean, wouldn't it?
Yeah, it's quite elegant. Something like C# string order ID starts with B, console write line, ordered ID.
That really pulls together the array, the foreach loop, and the conditional if with the starts with method. A great example of combining these concepts.
Absolutely. It shows how you use these fundamental building blocks to actually process data and extract meaningful information.
Okay, as we start to wrap up this deep dive on C# arrays, let's quickly hit the main takeaways.
Sure. So key things. Arrays are for ordered sequences of similar data. You access elements using that zero-based index, starting at 0.
Right, and don't go past the end. Watch out for that index out of range exception.
Definitely. The length property tells you the total number of elements, which is super useful.
And foreach is your friend for easily looping through every element without messing with index numbers manually.
Exactly. It simplifies iteration a lot.
Thinking back to that initial problem, managing lots of potentially fraudulent order IDs arrays clearly give us a much better way to handle that compared to like having a separate variable for every single ID.
Oh, absolutely. It provides structure, organization, and the means to process them systematically. Way more manageable.
So a final thought for you listening, this idea of ordered collections like arrays pops up everywhere, not just in code.
That's a great point. Think about any list you manage in real life, groceries, tasks, steps in a plan. How do you organize them? How do you go through them?
Now that you understand the basics of how arrays structure data with indices and allow efficient looping, maybe think about how that concept applies elsewhere. Could you organize some real-world list or sequence more effectively using these ideas? Something to ponder.